Hey everybody, welcome back to another edition in Geometry. Mr. A here. We're in section 11.2 today. We're going to talk about the area of trapezoids, rhombi, and kites today. Alright, so our objectives today, we'll find the area of trapezoids, and number 2, find the area of rhombi and kites. Okay, so first of all, what is a trapezoid? We've talked about this before, but we need to remember this. So trapezoid, it's a quadrilateral, means it has 4 sides. With one pair of parallel sides. So remember, a parallelogram has both opposite sides are parallel. A trapezoid, just one pair of opposite sides are parallel. So that would look maybe something like this. We've got, best I can here, these are, let's say those are parallel, okay? Because apparently I am not drawing very well today, but we'll call those parallel lines. And then you've got maybe something else here like this, okay? So this would be an example of a trapezoid where these two lines are parallel, but these two lines are not. Okay, so here's a better drawing of it than I could do. The area of a trapezoid in this case, remember in a trapezoid you have two bases. Remember the two sides that are parallel are both bases. So you have a base 1 and a base 2. And then the height would be the distance from the one base to the other base. So that's your height in this case. And so as you can see over here, our area formula is just 1/2 the height times base 1 plus base 2. Notice it's kind of similar to the triangle. Remember our triangle was 1/2 base times height. The only difference here is we've got what? We still have the height, but we have two bases to add together. So instead of 1/2 base times height, we have the base 1 plus base 2. So it's also key there to notice that you're adding those two bases together before you multiply it times height. Okay, so keep that in mind. Remember, you're adding, not multiplying there. All right, let's look at an example. All right, let's find the area. This is a razor blade, and we want to find the area of that razor blade. How much steel is it going to take to make that? And so you notice it's a trapezoid. You notice that these two sides are parallel to each other, and they've given us the height here. So all we need to do is just plug in. Remember, area equals 1/2 times the height times base 1 plus base 2. So we'll just plug it into that formula. 1/2 height is 1. Base 1, well, just doesn't matter which one is which, but we'll call that 3 plus 2.5. Okay, so when we work this out, we've got 1/2. Since it's times 1, does that really matter at all? Not really. And so we just have 3 plus 2.5, so that's 5.5. Because anytime we multiply any of this stuff by 1, it's still going to be the same. So really all we have to do is just do half of 5.5 for our area there. And so that should be then 2.75 if I am correct there. So 2.75 centimeters squared. Again, since we're talking about area, that's going to be in square units. Okay, so just 1/2 of 5.5, or 5.5 divided by 2. Not too bad, right? All right, how about this? We got a little bit trickier thing here. At first you go, hey, this isn't bad. But notice, remember, I'm going to write this out here again. So we've got the area equals 1/2 height times base 1 plus base 2. Well, what do we know? We know we've got the height is 4 here, right? Here's the two parallel sides. So the height is what's the distance in between them. So that's going to be 4. And B1, well, okay, we got 9. Here's one of our bases. But the problem is, we don't know what this is over here. That's our other base. We don't know what that is. How could I find that? All right, well, here's what you can do. You do know this side over here, and so we're going to kind of fall back on our old trick of drawing a line in here and making a triangle. Okay, it's not the straightest of lines, but we're going to say that that makes a 90-degree angle there. Okay, so what do we know in this triangle? We know that this side is 5. We know we've got a right triangle. This is 4, so the distance between these two parallel lines is 4, so that means it also has to be 4 over here as well. And so what we're trying to find is we're trying to find out what's this x here. We know the whole thing is 9, but we don't know what this part is. Okay, well, this might be a good time to bring up Pythagorean triples again. Remember, we've talked about those before. 3, 4, 5, or 5, 12, 13 are a couple of the ones I said are really important to remember. Notice here, you've got a 4 and a 5. What might be a Pythagorean triple that uses a 4 and a 5? How about a 3? 3, 4, 5. So we could go through, and remember, again, the 3, 4, 5 works when the 5 is the hypotenuse, okay? And the 3 and the 4 are the two sides here, the A and the B. And so we know that this is 3. And so we've got 3, 4, 5. You could go through and work out the Pythagorean theorem there, x squared plus 4 squared equals 5 squared, and work it all out. You're going to get 3. So this is a case, again, where if you can remember the Pythagorean triple 3, 4, 5, it's going to save you a lot of time. All right, so if this is 3, if this distance is 3 here, and the whole thing is 9, well, what's left? What's this part that's left here? It's got to be 6, right? Which is the same as this one up here. That's our other base that we're looking for. And so we can just plug 6 in here. And so now we can continue on our journey. And so we've got 1/2 times 4 times 9 plus 6 is 15. I'm just going to go 1/2 times 4 first. What's 1/2 times 4? 2. So we really just have 2 times 15, which will be 30 feet squared. Okay? Does that seem okay? So again, the key here is, you know, you've got to draw this line in here, make a triangle, and we can do the Pythagorean theorem there, or use a Pythagorean triple. All right, now in this case, we already know what the area is. We know it's 210 square yards. We're going to try to find the height. So we use that same formula. We just plug stuff in where it goes. So the area is equal to 1/2 times the height times base 1 plus base 2. We plug in what we know. Before, we've been plugging in the two bases and the height. Now we know the area is 210. So let's plug in 210. The height is what we do not know. So that's h. We know the two bases. What do we have? 20 for one base, 50 for the other base. Okay, so let's start working this out. We got 210 equals 1/2 times height times 70. What I'm going to do here is remember the commutative property of multiplication means you can multiply stuff in any order you want to. So I'm going to do 1/2 times 70 first, which is, what's 1/2 of 70? 35. So really what I've got here is 35h. 35 times h, and then I can divide by 35. And so what we end up here with is, I'm going to get my calculator for this one, 210 divided by 35. And it looks like we got 6. And so the height, we were looking for the height of that, and so that's going to be 6 yards. That's all we were looking for. It was just how many yards, or what's the height there, 6 yards. Okay, so you can use that same formula if you're missing any of the measures in a trapezoid. All right, lastly, we're going to talk about rhombi and kites. Okay, a rhombus is a parallelogram with all 4 sides congruent. So if you remember, it's going to look something maybe like this, kind of a diamond shape, where all 4 sides, all 4 sides are congruent. That's what a rhombus is going to be. And then a kite is a quadrilateral with 2 pairs of consecutive congruent sides. So typically what you see might be something like this, where you've got like those 2 sides are congruent to each other, and then you've got these other 2 sides are also congruent to each other, And so therefore it kind of looks like a kite, like you typically think of a kite, you know, that you fly up in the sky. Okay, so that's what a rhombus and a kite is. And so let's take a look at their areas. Interestingly enough, their areas have the same formula, which is kind of cool. And so if you notice here, the diagonals, remember a diagonal is from one corner or vertex across to the other side, so that's a diagonal. And so we have two diagonals in both of these shapes here. And so our formula for the area is just 1/2 times diameter 1, or diagonal 1 times diagonal 2. So whether it's a rhombus or a kite, we've got the same formula. Okay, so a kite. Well, what's the area of a kite? Remember, what's our formula? Area equals 1/2 diameter 1, I keep wanting to say diameter, diagonal 1 times diagonal 2. And so in this case, well, 7 feet, that's one of the diagonals. 12 is the other diagonal, so all we have to do is plug it in. 1/2 times 7 times 12. Again, if I wanted to, I mean, I could just plug this in my calculator, but remember, you can multiply this in any order. I could just go 1/2 times 12, which is 6. So really, we've got just 7 times 6, which is 42, and that would be 42 feet squared. Okay, pretty simple. What about a rhombus? Well, in this rhombus, remember the thing about rhombi, if you remember, the diagonals will bisect each other. And so that means in this case, and it even kind of gives you the hint here because it marks them as being the same, but if this is 9 inches, this will also be 9, and if this is 7, this will also be 7. And so when we go to plug in our formula here, we have 1/2 diagonal 1 times diagonal 2. Hey, I said diagonal that time instead of diameter. So when we go to plug this in, the first diagonal would just be 7 plus 7, or 14. And the second one would be 9 plus 9, or 18. And so again, here you could just plug this all in your calculator, or just do part of it. You know, 1/2 of 14 is 7. So you could just say, oh, this is like 7 times 18, which still that might be not the easiest thing to multiply together in your head, but you could just go 7 then times 18. So 126 there. And since again we're finding the areas, that would be the area that would be in inches squared. Okay, so 126 inches squared. All right. Now we'll find a missing measurement here. Okay, so we're going to use this stuff to find a missing measurement. We know that this is going to be kind of fun. One diagonal of a rhombus is half as long as the other diagonal. If the area is 64 square inches, what are the lengths of the diagonals? Okay, so we're going to start back. Our formula, area is 1/2 diagonal 1 times diagonal 2. But notice we don't have any numbers here, okay? But what we do know is we know that we've got the area is 64. So we'll plug in 64. And the 1/2, well, that's just going to be 1/2. What can we do with the diagonals? Well, remember, here's what they've given us. They said one diagonal is half as long as the other. Well, if you look at this, you go, it looks like the RT is going maybe is half as long as the US. So you're going to pick a variable to use. Remember, whenever we don't know a number, we can use a variable to help us find that. Now, the key is you have to use the same variable. You can't call one diagonal A and one diagonal B. That's not going to get you anywhere. You have to use the same variable. Well, since it told us that one was half as long as the other, you could go about this two ways. I'll show you both, but I'm going to go the easy way here. You could say, oh, well, if I call US, if I call that X, and then I could call RT 1/2 X, because it's half as long. That's great. It works. But what do you have? A 1/2. You've got another 1/2 in there. and you've already got a 1/2 in the formula, so it's gonna start getting kind of complicated with fractions. Why don't we just, instead of call US X, why don't we call the short one, let's call the RT, let's call that X, and then if we make that one X, then the other one's going to be twice as long, or 2X, right? So instead of X being the long one and 1/2 X being the short one, go the other way. X is the short one and 2X is the long one. That's going to be a lot nicer because we'll have a lot less fractions to deal with. And if you notice here, when we go to work this out, so remember again, these are all just being multiplied. It's all 1/2 times X times 2 times X. So I'm going to choose to multiply 1/2 and 2 here first. What's 1/2 of 2? 1, right? So basically they just cross each other out. We can just cross those out, and all I've got left is X times X, or X squared. And so how do we undo squaring something? We take the square root. And so we take the square root of both sides. That means X is 8. And so that means, and X, remember, was our diagonal RT. So RT will be 8 inches, and then the other diagonal will be twice that long, so US will be 16 inches. Cool, right? Okay, excellent. Good. Any questions on that? All right, one more thing before I go. A little review of the things that we've talked about in the last couple of sections here. So as you can see, again, parallelogram, whether this kind of looks like a normal parallelogram and you've got base and height, or if you know this base but they give you the height this way, kind of on the outside of it, it's still area equals base times height. Remember triangle, whether it's a normal triangle like this where you have the height inside, or if it's a triangle where the height is outside, it's still going to be 1/2 base times height. And the trapezoids that we just talked about, remember it's 1/2 height times base 1 plus base 2. That's our formula there for trapezoids. And then finally for the rhombi and the kite, whether it's a rhombus like this one or whether it's a kite like this one, either way, 1/2 times the diagonal 1 times diagonal 2. So there's a little overview of the different areas of the last couple of sections. All right, appreciate you being here, Mr. Anderson, and I hope you enjoyed it. We'll talk to you next time in section 11.3. Bye.